Hey, welcome back to the much anticipated second rose graph video. Hopefully this one will be shorter than the first one. We're going to start with the formula sheet that you guys got in class. Um, if you can, pause the video and try to just fill in all the blanks with the things that I have up here and that you don't have on your sheet. Go ahead and add this stuff in here. And then I'll take a moment to kind of talk about a few things before we go to our next example. Okay, so what I want to show you first here is that, kind of how I have this broken down. Obviously, we're talking about cosine here, sine here. Let's focus on the cosine one first. Remember, the cosine graph, when we graphed it, the first petal started out at the maximum, and then we came back in towards the pole, just like a cosine graph starts at the maximum, comes back in towards uh, the r value of 0, or the y value of 0 in that case. So this says the first petal starts at theta equals 0. Really, it's the first petal tip is at that spot, because all of these graphs are going to start at a theta value of 0. It's the graph really doesn't start here. It actually starts, if you remember from our first video, the graph actually starts here. Actually, I'm sorry, if it's cosine, it does start here. My fault. If it's cosine, it does start here, and then it starts working its way back into the pole. Okay, but it's the sine graph that doesn't actually start at the petal tip. The cosine one does start at the petal tip, and it'll be at a polar point of a comma 0. All right, so whatever a is, that's what that distance is to that point right there. If it is a sine graph, like I said, the theta starts at 0 actually, but the first petal tip is going to be found out here at a fourth of the period. Well, that would be pi over 2n then. So that's where that's coming from. It's a fourth of the period. All right, so it's not really where the graph starts. The graph starts at 0, but the first petal tip is going to be out at pi over 2n. And that's the angle, and obviously it'll be a units away from the pole. And then we have some things here about the that are universal. N tells us the number of petals. It's the same if it's odd, double if it's even. The period is 2 pi over n, just like 2 pi over b for both of these. And then we kind of talked about this in the last video, because we did some odd graphs, that you have to graph values from 0 to pi if you're making a reference graph, okay? But the other thing that we're going to be talking about here is the fact that, well, it's the top of my pi there. Happy Pi Day, by the way. We are going to use some shortcuts to graph these now. We're just going to plot that first petal, which is why we have this, and then we are going to just add, if it's odd, the period 2 pi over n to get to the next petal. Okay, if it is odd, then these functions are symmetric in different ways. All right, let's talk about if it's even. If it's even, then we actually have to graph from 0 to 2 pi. These are the types of graphs we're going to be looking at closer today. There are 2 n petals, and instead of adding the period between each petal tip, we have to add half the period, which is pi over n. And an even graph is symmetric in both the x and y axis or in the pole. Okay, so let's take a look at example 3 here. I actually want to go back to the one I was working on before. Where was I? There we go. So here we are, example 3. Okay, maybe pause the video, take a second to write that equation down. I'm not sure if you do need to write all this stuff that I have written here. It might be getting a little overboard. Kind of write things as you see fit, but let's go ahead and start graphing this then. Notice first that this is going to be symmetric since it's a cosine and this is even. Well, the fact that it's even kind of trumps the fact that it's a cosine. It's going to be symmetric in the origin, okay, or the pole. And that means that it's symmetric on both the x and y axes. Okay, it doesn't matter if it's cosine or pi, or cosine or sine. The petal length is going to be 5 because a is 5. We are going to have 4 petals. n is 2, which is even, which means we're going to have 2n or 4 petals. The period is 2 pi over n, which is 2, so the period is going to be pi. Now, it's a cosine graph, so the cosine graph's first petal tip starts at an polar coordinate of a comma 0. Well, a was, can't remember, 5. So it's going to be the maximum point away. That's the max r value. So at 5, 0, 5, 0 radians, okay, that's not the point 5 comma 0 like x comma y. I'm having a hard time with my zoom with this thing today. So we're going to go out to 5 here. Let's just number on this axis. 1, 2, 3, 4, 5. So at 5, 0, we are going to be right here. Okay, that's our first petal tip, and it's actually our starting point for a cosine graph. Now the period is pi, so that means that we are going to add pi to get to the next petal. So the next petal is going to be, next petal tip is actually going to be right here. Okay, so this is my first petal tip. This is my second petal tip. Okay, now the A, B thing, that's not the exact same as what we had before, because there's actually going to be some points at the pole as well, or at the origin. But what we know we're going to do is we are going to start at this A and then come back down through, and we're going to come to the B and then come back to the pole. Okay, and then what it's going to do, and that would be at the point. Let's see here as we're opening this up. Actually, let's just use how many petals we're gonna have. We'll keep adding that pi. My next petal tip then is going to be down. Let's get our mark here, right here, on the y-axis at which is actually the pi over 2 point, but it's going to have a negative r value, so I'm down below here. Okay, so if we want to show our arrows as to how this is being graphed here, this is actually the order. Okay, and then I came back down through, and here we are, and I come back here. Okay, and then my let's see, I don't have all these marked on my notes here. I have my point up here. There we go. I'm going to come back down. And then I'm going to finish here. So it has 4 petal tips. Oh, that's right. That's where I was messing up. The period is pi. Okay. The period is pi. But to get to the next petal tip, I got a little ahead of myself here. Since we have an even number of petals, we really are taking pi over n, which is 2, to get to the next petal tip. So from here to here is pi over 2. Now that's the next petal tip on the graph. Like I said before, how it's actually graphed is in the order that I showed there, which would, if we want to show all the points, would be A, B, and then C, and then this is D, and then we went down here to E. Sorry, this was C. And then we came here to D, and then we were at, oh, I can't wait for swing break. Nope, that's D. That's D there, so this was E. There we go. A, B, C, D, E, and then we came back here to F, to G, to H, and this is just for the purpose of connecting it to a reference graph if you wanted to, or if you really wanted to see what order these are graphed. What we are going to be interested in doing, though, is once you start understanding kind of how these graphs are, the symmetry are, is getting rid of all the letters there, and even these little arrows right here, and you're just going to put down where your first pedal tip is, which is this point right here, and then you're going to go, okay, this is even, so I'm going to add pi over 2 to get to the next pedal. So here would be the next point, and then here's the next point, there's the next point, and then you can simply just sketch these in. You don't have to worry about what order they're going in. I just want you to know what these graphs look like. So this would be a 4-pedaled rose graph. It is symmetric in the pole or in the origin, or both the y and the x-axis, because it has an even number of pedals. And that's what we're interested in doing here, okay? All right, let's take a look at example 4 here. I still have these on from the very first example. All right, in example 4, it's going to be our last one here for our rose graph. In example 4, we have an even number of, for n again. N is 4, which is even, which means we're actually going to have 8 pedals. And the pedal length is going to be 3, because A is 3. The period is 2 pi over n, which is 4, which is pi over 2. Okay, so that's the period of this thing. Because I have an even number of pedals, I know that I'm going to have, double that n value, 8 pedals. And to go from one pedal to the next, I need to go half the period. So I'm kind of down here right now. To go half the period, that means I have to go pi over 4 to get to the next pedal. Okay, pi over 4 to get to the next pedal. So my first pedal, since this is a sine graph, is not going to be on that polar axis. We need to recognize that it's a sine graph and say, well, this is then going to be at 3 comma and then 1/4 of the period. Well, 1/4 of the period would be pi over 8. Okay, that's where my first pedal is going to be. Pi over 8 is half of pi over 4. Pi over 4 is right here. So half of that would be about right there. Okay, there's pi over 8 right there. I'm actually going to put this in. Maybe I can even get this in with a little bit nicer line here. All the way across. Oh, I love this thing. I don't understand. All right, never mind that. Okay, because I know I'm going to have other uses for these lines here. So I'm just going to get ready to mark them here, because in between each of those would be pi over, this would be 3 pi over 8, which means that I'm adding pi over 4 to get to it. So I know that I'm going to go from one to the next there. Let's get this one in here. And then finally, I don't think I have this one yet. Those are all going to come in handy here. So my first pedal tip is right there, because it's a sine graph. Okay? And a sine graph, going back to the whole reference idea, starts at its maximum value, in this case 3, before coming back down towards the pole. So this is going to start there. Now, instead of drawing this thing in the order that each point is graphed, we're going to now just take our formula sheet or the ideas that we've learned here and put together the fact that I can get from one pedal tip to the next by just adding half the period. Half the period, because it's an even n value. So half the period is pi over 4. So that would put me here, and then my next one would be here, and I'm just adding pi over 4 every time. There are the pedal tips I'm going to have. Okay? Now, this has nothing to do with this graph right now, but imagine if this were a cosine graph and the values are the same. Okay? This would be, and by the way, I just realized that I put my points way out there, so let's go by 2's here, why not? Or by halves, I mean, so this is 3, this is 2, and this is 1. Okay, now if this were a cosine graph, then it would start right here. right there, in case you can't tell where I'm at. Okay, and if I added pi over 4 each time, it would put me at these pi over 4 angles like this, and I'd still have 8 petals, and they'd still be half the period apart. Okay, but it would now be shifted and have different petal tips than the one that I have right now with the sine function. Just to throw that out there, it wouldn't start. It would start on the polar axis instead. So let's just graph these petal tips in, or these petals. So there's my first petal. Okay, here's the next petal I'm going to graph. Next petal I'm going to graph. And there we go. 8 petals, symmetric in both the x and y axis, and a petal length of 3. So that is our final rose graph example.